What if the universe doesn't kill us by accident but by indifference? Faster than our minds can even notice. There is a reason audiences keep returning to questions about death in space. Not because of spectacle, not because of shock value, but because extreme environments strip away metaphor. On Earth, death is tangled in emotion, story, and meaning. In space, death is physics, immediate, indifferent, absolute. At Deep Space Inquiry, we don't ask these questions to dramatize fear. We ask them because extreme cosmic environments reveal truths about reality that everyday life hides. They show us the limits of biology, the limits of perception, and the uncomfortable fact that the universe does not adapt to us, we must adapt to it, or vanish. So instead of comedy beats and quick cuts, let's slow this down. Let's restructure the journey. And let's talk about what these places actually teach us, not just how fast they would erase us. We think of the sun as gentle, warm, familiar, life-giving. That perception is a trick of distance. From 150 million kilometers away, the sun becomes manageable, filtered through atmosphere, moderated by orbit, softened by scale. But remove that distance, and the illusion collapses. In 2024, Parker Solar Probe skimmed the outer edge of the solar corona, entering a region hotter than the visible surface itself. This alone exposed a lingering mystery. The corona reaches millions of degrees, while the surface below remains cooler, a violation of intuitive thermodynamics that scientists are still struggling to fully explain. If a human body were placed at the photosphere, the closest thing the sun has to a surface, death would not feel dramatic. It would feel like nothing. At roughly 5,500 degrees Celsius, molecular bonds fail instantly. Neural signaling cannot occur. Pain requires time, and the sun does not grant it. Here's the deeper truth. The sun is not hostile. It is simply doing what stars do. Life exists not because the sun is gentle, but because we orbit at a precise distance where violence becomes generosity. The moment that balance shifts, life is no longer negotiated, it is terminated. Black holes are often described as cosmic vacuum cleaners. That description is wrong and misleading. A black hole does not pull harder than any other object of equal mass. What makes it lethal is not strength, but geometry. Space curves so extremely that escape paths cease to exist. Near Gaia BH1, a stellar mass black hole roughly 10 times the mass of our Sun, tidal forces dominate. These forces stretch objects vertically while compressing them horizontally, a process called spaghettification. From the outside, an observer would never see you cross the event horizon. Time dilation would freeze your image forever at the edge. But from your own perspective, time continues normally right until structure fails. Bones do not break. They elongate. Atoms do not explode. They are rearranged by gravity. Contrast this with Sagittarius A star, the supermassive black hole at the center of our galaxy. Its enormous mass means tidal forces near the event horizon are gentler, ironically allowing a human to cross the horizon intact, only to die later, deeper inside. The lesson is unsettling. Death near a black hole depends not on drama, but on scale. If black holes break space, neutron stars break matter. A neutron star compresses more mass than our sun into a sphere barely 20 kilometers wide. Under that pressure, atoms cannot survive. Electrons are forced into protons. The distinction between particles collapses. What remains is not solid, liquid, or gas, but a single continuous nuclear substance matter stripped of structure. Approach too closely, and death arrives before contact. Magnetic fields trillions of times stronger than Earth's would overwhelm any spacecraft, scrambling electronics and disrupting neural signals inside the human body. Gamma radiation would tear through cells faster than biology can respond, breaking DNA apart before pain or awareness can form. Gravity here does not merely pull, it differentiates. Your feet would experience far more gravity than your head. The body stretches not violently, not explosively, but inevitably, until coherence itself fails. Bones, tissues, and cells lose their alignment, not because they break, but because they can no longer remain whole. Neutron stars reveal a brutal truth about the universe. There exists a density beyond which complexity cannot survive. El Gordo is not a place you land. It is a place you enter too late. Born from the collision of two massive galaxy clusters, El Gordo is a region where entire collections of galaxies are locked in a slow-motion catastrophe. The space between those galaxies is filled with gas heated to over 160 million Kelvin, hotter than the cores of stars spread thinly across intergalactic space. This heat does not burn like fire. It does not flicker or fade. It ionizes. Electrons are stripped from atomic nuclei. Matter loses its identity and becomes plasma. As clusters collide, enormous shock fronts propagate through this gas at thousands of kilometers per second. Any structure passing through would be shattered long before temperature alone becomes relevant. This is not a single explosion or a brief flash of destruction. It is sustained violence, unfolding across millions of light years, lasting for hundreds of millions of years. El Gordo reminds us that the universe's most destructive events are often the slowest, vast, patient processes that continue long after stars are born and long after civilizations would already be forgotten. Supernovas are often described as the deaths of stars. That is only half the story. They are also acts of creation. In the final moments of a massive star's life, elements heavier than anything forged in normal stellar cores are born: iron, gold, uranium, the raw materials that make planets, bodies, and civilizations possible. SN 2016 APS stands among the most energetic supernovas ever observed. Evidence suggests it formed when two massive stars merged before collapsing, storing extraordinary energy before releasing it all at once. For a brief moment, the explosion outshone entire galaxies. At close range, death would arrive without drama. Neutrinos would pass through the body, first invisible, unstoppable, interacting directly with atomic nuclei, heating and rupturing cells before the nervous system could respond. Then comes the shock wave, moving faster than perception itself. There is no awareness, no final thought, only transformation. Every atom that once formed a body is scattered into space, becoming raw material for future stars, future worlds, and perhaps future observers. Still asking the same questions about how everything begins and how everything ends. Here is the uncomfortable pattern that emerges when we look closely at the universe. The universe does not kill slowly. It kills efficiently. In extreme environments, sensation disappears before awareness can form. Identity dissolves before thought can complete. There is no cruelty in this process, only consequence, unfolding according to unbreakable physical laws. Seen this way, survival itself becomes something extraordinary. Life on Earth is not a default state. It exists only because countless variables align within an incredibly narrow range. The right distance from a star, the right atmospheric pressure, the right chemistry, the right timing across billions of years. We are not built for the universe at large. We are built for a fragile pocket within it, a temporary zone of tolerance where complexity is allowed to persist. Outside that zone, structure fails quickly and without negotiation. This realization is not nihilistic. It is clarifying. It reminds us that existence is not guaranteed, not owed, and not permanent, and that every moment of stability we experience is something rare, improbable, and worth understanding. At Deep Space Inquiry, we do not explore these places because we want to imagine dying. We explore them because they reveal what it means to live at all. By confronting environments where survival is impossible, we gain clarity about the narrow conditions that make existence possible here. The sun teaches restraint. Black holes teach humility. Neutron stars teach limits. Supernovas teach continuity. Each extreme environment strips reality down to fundamentals, showing us that life is not the universe's default outcome, but a rare alignment of balance, timing, and stability. The universe was not designed to care about us. Its laws operate without preference or intention, and yet, within that vast indifference, consciousness emerged. So when you look up at the night sky, remember this. Every calm moment on Earth exists between forces powerful enough to erase us instantly. We live within a fragile window, a brief permission granted by physics itself. And it is that fleeting allowance, temporary, improbable, and unrepeatable, that makes being here matter at all.